So, 3.5 notes. Again, I'm sorry I don't have sheets for you. You don't have to write it all down. You don't. If you want to, you can. Whatever you choose to write down, it is up to you. I think you should write down the example problems we do. But as far as this is concerned, if you just simply follow along with what I'm saying, I think you should be fine. So, complex numbers in the fundamental theorem of algebra. Now, this is not what the fundamental theorem of algebra says exactly, but it's very similar to this. I wrote it in a language that we could better understand and comprehend. If a polynomial has degree n, how many solutions does it have? N. If a polynomial has degree 4, it has 4 solutions. If it has degree 8, it has 8 solutions. Okay? So a polynomial of degree n has n solutions. We've known that, right? Let's end with this though. And it can be written as a product of n factors. So for example, let's suppose that C is my solution. Okay, C sub 1 is a solution, C sub 2, C sub 3, all the way through C sub n. Let's suppose that those are the solutions. Then you can write it in factored form. You might have a constant like A out front that doesn't change the solutions, but then you can write it as x minus C sub 1, x minus C sub 2, all the way till you get through the nth solution. Okay? Now, I don't think that that's surprising to you guys. We have been doing a lot of type of factoring using rational roots theorem, right? And you guys have found a lot of solutions. We've found solutions to 3rd degree, 4th degree, 5th degree. I think even one of your assignments had a 6th degree polynomial, didn't it? So we've done all this, and we can write those in factored form. Today we're going to put it together, and we are going to also put this statement on the end. Okay, I said this yesterday, and we're gonna really internalize it today. If there are complex solutions, they come in pairs, right? Here's an example. If 1 plus I is a solution, then its conjugate is a solution as well. What's the conjugate of 1 plus I? 1 minus I. So if you ever see a complex solution, you know it has a pair, and you know its pair is going to be its conjugate. Okay? Everybody okay with what I said? We'll practice it. Hopefully you're okay with what we said. All right, let's try this problem. Example 1. Okay? Here's your first example. Example 1. Solve 8x to the 3rd plus 1 equals 0. This one has a real solution. It also has 2 complex solutions. You're going to see it play out here in a second. Okay? And you have a few methods you can use. You can either solve it algebraically, you can factor it, or you can use the rational roots theorem. Now, I don't want to use the rational roots theorem here because I see that it factors. Now, I'm bringing up a factoring method you guys maybe haven't seen for a while, but do you recognize this factoring here? Very good. Sum and difference of cubes. I'll write them both down in case you need to know them again. If you have a to the 3rd plus b to the 3rd, that factors to a plus b times b squared. What? Slow down. A squared minus ab. Hi there. Plus b squared. If you have a to the 3rd minus b to the 3rd, a minus b times a squared plus ab plus b squared. So that's the sum and difference of cubes. So we're going to factor this as it's the sum of 2 cubes. And when I factor it, a to the 3rd becomes a. What's the cubed root of 8x to the 3rd? 2x. Then I have the cubed root of b to the 3rd. What is the cubed root of 1? Then look at your formula, everybody. It tells you to square a. If I square a, I get. Then it says subtract those 2 multiplied together. 2x times 1 is 2x. And then it says square b. There I have it. So sometimes factoring is a better method than rational roots theorem or synthetic division. Let's now look at our solutions. What's the solution here? Negative 1/2. If you factor the sum or difference of cubes, and it's the third degree polynomial, this part right here will never, ever factor. If it doesn't factor, what do I have to use? The quadratic formula. Everybody, please take careful note of the quadratic formula. I know on some of your tests, people forgot the b squared and just wrote the b. You have to square the b, all right? So make sure you got the quadratic formula correctly. I know that you know that because you bought bunk beds over break and put this paper up on the ceiling so you can look at it every night before you go to bed, right? You know what you're going to say bunk beds because in college when you get in your dorm, everybody's got a bunk bed. And so every once in a while you do keep your notes there as you're studying, trying to get some sleep. 3.5 hours some nights so you could get ready for your test. Just the way it goes. You guys think I was a studier or a partier in college? What's it? Sydney? Oh, you? No, it was not a partier. I can't believe you think that, Sini. I'm disappointed. All right. Negative b. What's negative b? Positive 2. Plus or minus square root of b squared? 4 minus 4 times a is 4, c is 1, divided by 2a is going to be 8. Quadratic formula is just another way of completing the square. It's just we have a formula for it. So we have x is equal to positive 2 plus or minus. What is 4 minus 4 times 4 times 1? Negative 12. Square root of negative 12 divided by 8. Square root of negative 12. What is that simplified to? Square root of negative 4 and the square root of 3. What's the square root of negative 4? 2i. So we have 2i roots of 3 is what that will simplify to. So our solutions become 2 plus or minus 2i roots of 3 all over 8. What can you take out of all of those? A 2. If I reduce by a factor of 2, I get 1 plus or minus I roots of 3 all over 4. Okay. Remember what we did yesterday with complex numbers? Can I leave it in that form? No. We need to write it like this. We have a real part and we have an imaginary part. And so we're going to write this as 1 over 4 plus the root of 3 over 4 times I. And we'll do 1 over 4 minus the root of 3 over 4 times I. Yes. Well, it's just that I want to do something else. So you'll see in a second. You'll see in a second. So I'm going to list off my 3 solutions. I'm going to do something that nobody's really found interesting yet, but hopefully you guys will because you're the best. So our solutions are negative 1/2, we said, 1 over 4 plus the root of 3 over 4i, and 1 over 4 minus the root of 3 over 4i. Everybody agree that those are my 3 solutions? Okay, so here's what the fundamental theorem of algebra says. It says 2 things. Number 1, if it's a third degree polynomial, it will have how many solutions? 3. And it also says that every single polynomial, even this one, can be written in a fully factored form. And here's that fully factored form. Now you don't have to write this for your assignment, but I want to show you because this is going to help you with a couple problems later on. Here's how you can write the fully factored form. It's always x minus whatever the solution is. So it's x minus negative 1/2, which, yes, you could write as x plus 1/2. It's x minus 1/4 plus the root of 3 over 4i. And it's x minus 1/4 minus the root of 3 over 4i. So my point is that this factors to that. Now, we couldn't teach you how to do that, right? I mean, you would have to go through the process we did. It's not like you could just see, oh yeah, duh, it's going to factor to that. Here's the other neat thing. If you flip it around, if we take this and we multiply it all out, what are we going to get? Yeah, if we multiply this all out, we would get 8x to the third plus 1. These are the same expressions. And the fundamental theorem of algebra says that. And I know it's hard to see now because you haven't seen Calculus 2 and other pieces, but this is so user-friendly. It's amazing how since this piece developed, in the 16th, 17th centuries, how much we're able to develop other areas of mathematics and how useful it was. So the fact that this factors to that is awesome, okay, and very useful for us. Now note that there are some complex pieces to it, but that's okay. The fact that it does that is great. That was a pretty involved problem. You want to see an easier one? Let's see an easier one that we can wrap our learning around. Let's do example 2, x to the 4th minus 16. So last hour I said, Mr. Gibbs, you showed us the difficult one first. That wasn't very smart. Maybe, I guess. Sorry if that doesn't connect for your learning. I'll try harder next year. X to the 4th minus 16. Does that factor? If it factors, just factor it, okay? You can use the rational roots theorem, try plugging in 1, 2, 4, 16, 8, and then the negatives. But if it factors, factor it. And it factors to x squared, and then what? Minus 4 and plus 4, because it's the difference of two squares, right? We know that it's going to have 4 solutions. We know that it's going to have 4 factors. X squared minus 4, does that factor? X plus 2 and x minus 2. Does x squared plus 4 factor? Now see, this is the interesting thing. Some people said no on previous hours and some people said yes, and they're both right. It doesn't factor in a way that we've learned before in Algebra 2 or College Algebra Precalculus, but it can be expressed in factored form. If we take x squared plus 4 and set it equal to 0, we can solve that. X squared equals negative 4, square root both sides, and x is equal to what? What's the square root of negative 4? Plus or minus 2i, right? So look at what we have. What's the solution here? 2, positive 2i, negative 2i. So you can see you have 4 solutions. So yes, this does fully factor. X minus a negative 2 times x minus a positive 2 times x minus 2i times x minus a negative 2i. And yeah, if you write it out, you want to write x plus 2 and x plus 2i instead, that's fine. I'm just saying the fundamental theorem of algebra states that you can write as x minus for all those solutions. So again, the question is, does this fully factor? Yeah, it sure does. It factors to that. Factors to that. Bryn? That's just the way we end up writing it. For example, let's say that let's say 4 was a solution. Then if we wrote it as x minus 4, so if I subtract 4 from both sides, I get 0. So it just always ends up being that if x is equal to a solution, we'll call C1, if we subtract that to the other side, x minus C1 is equal to 0. Therefore, it's a solution. So that's why we write it as minus. Okay, Krista? Okay, all right. So on your assignment for the first part, you don't have to write it in the fully factored form. You just need to list the solutions. And this one was nice and easy because, you know, it factored difference of two squares pretty quickly. Okay? Let's try another one that's pretty straightforward and simple. Okay? Let's do this third one. X to the third plus x squared plus 64x plus 64. Sydney, I can't take my eyes off your finger. So what happened? Shattered. Got a couple breaks in it. Okay, it's just a finger. There you go. All right, that's the attitude. I've broken a few in my day. This one right here, it does come out and join a little bit. You can put it totally sideways. I dove for basketball in 6th grade and it popped out. I mean, it was sticking like, well, it was sticking like that, and so I knew right away that if my coach saw it, he wouldn't let me play. So I just took my finger and I just squeezed it, thinking it would go straight. But when I popped it back in, it tore the ligament. So like if you hold my fingers, you can bend that part, but the pinky won't bend. It relies on the movement of everything else. Or if you press down my pinky, I can't push against it. It's just kind of there. It took a while before I could type with it or anything like that. But it's still there. But it's just a finger, right? Yeah. Yeah, they told me, they said we could get the finger working again, but it would cost about 20 grand. We'd have to graft a new tendon, and I said, it's just a finger. It's the kind of thing you talk about on a date anyways, yeah, so, all right. Okay, here we go. Yeah, that's how I met my wife. That's a whole other story. All right, this one does factor. Do you know what method I use for factoring this? Grouping. So what can I take out of the first set? X squared. And you can take 64 out of the second one. And now what do they both share in common? Ooh, we'll see if you can see it right away. What's the solution here? Anybody see what the solutions are going to be here? Plus or minus 8i. Very good. So my complete factored form would be x plus 1 times x minus 8i times x plus 8i. You don't have to do that. I'm doing this because this is going to help you do what we do next. Okay? Yeah. So the next two examples, I'm going to show you how we use this. And one's going to be straightforward. The other one's going to be a little bit difficult, but it'll be fine. So this time I didn't write them as all minus. I wrote it. I thought, okay, x minus a negative 1 is going to be x plus 1, and I just wrote it like that. So. Are we okay with that? So this is the complete factored form. Okay, let's do the next objective that we want. We're going to change the directions now. Given a polynomial with solutions, I want you to write the polynomial. So before I give you the polynomial, you had to find the solutions. Now I give you the solutions, and you need to be able to write a polynomial. And I know that you woke up this morning and you thought about what do you want to do today, and you said, I want to write some stinking polynomials. I learned how to write a linear function back in 9th grade, but Mr. Gens has not taught me how to write a polynomial, and I demand that we learn that now. So I will answer the call. I will teach you how to do it. It's easy because we have the fundamental theorem of algebra. We know that polynomials can be written in factored form, right? A polynomial with solutions of 4 and I. Well, if 4 is a solution, what's a factor? X minus 4. Genius. If I is a solution, what's a factor? X minus I. Uh-oh, anybody see a problem here? I've only got one I. Oh, Oh, you guys caught me. You 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 know what happened yesterday? Luke Sunblack caught me. He caught me with that, and I said, "What happens if I have 3 eyes?" And so he piped up from the back and I said, "I don't know. Why don't you tell us what happens if you do have 3 eyes?" And everybody started laughing. I said, "Here's what happens. I'm still better looking than you with 2 eyes." And he laughed, so it was all good. Oh, well, I don't know. Then I have a parent conference or something, I suppose. Okay, so there's only one complex solution here, and that's I. But you've learned if there's a complex solution, they come in pairs. And if I is one of the solutions, what's going to be the other one? So, watch. I can rewrite I as 0 plus I. Those are the same, right? So, if I is a solution, its conjugate is a solution. What's the conjugate of 0 plus I? 0 minus I, or just negative I. So, we have x minus 4 for that one. We have x minus I for that one. Then we have x minus negative I, or x plus I. So, yep, that's the other factor. So we want to now multiply this out to get a polynomial. Should we multiply the x minus 4 and the x minus I, or should we multiply the x minus I and the x plus I? Yep, let's do that first. What's x times x? X times I. Negative I times x. Negative xi. And negative I times positive I. Negative I squared, which is 1. Look, negative I times positive I is negative I squared. And you know that I squared is negative 1. Negative 1 is positive 1. Carissa, ask the question. They will, yes. But do you see why negative I and positive I make negative I squared? And that is positive 1. Okay, so Carissa does see that the positive xi and the negative xi cancel. So you're left with x minus 4 times x squared plus 1. So we got rid of the i's. They should always go away. If they don't, you did something incorrectly. We got them to go away. So let's finish this off. Let's distribute through x times x squared. X times 1. Negative 4 times x squared. And negative 4 times 1. You should write it in descending order of powers. Done and done. I know you were wondering what polynomial has solutions of 4 and I. Well, that polynomial has solutions of 4 and I. That one right there. Yep, I'm positive. Because if we factored it, we would come back up with what we did in the beginning. That's what they said last hour too. They said, prove it now, Mr. Gens. I know what you're thinking now. You're thinking, Mr. Gens, that was too easy. We want to be challenged. Okay. Last example. Write a polynomial that has solutions of negative 3 and 4 plus 2i roots of 3. If I have solutions to the polynomial and I have one of them that's complex, complex solutions always come in pairs. And the pair is the conjugate. So if I have 4 minus 2i roots of 3, I also have 4 plus 2i roots of 3. You know that that's going to be the case. Well, let's use the fundamental theorem of algebra. It says you can write this all in factored form. x minus negative 3, or x plus 3, times x minus my first root of 4 minus 2i roots of 3, and x minus my other root of 4 plus 2i roots of 3. Oh boy. Okie dokie, what do you want to do now? That hurt my feelings. Alright, we don't want to erase it, we want to solve this bad boy. You want to come up with a polynomial that has the solutions that we want. So, what to do? Basic step here, basic step. Let's distribute that negative. Okay? We know we're going to have a lot of multiplying, aren't we? In fact, you got a trinomial times a trinomial. 3 terms times 3 terms. 3 terms times 3 terms is going to give you how many terms? 9. But fortunately, you're excellent at multiplying polynomials. We've tested on that. You did great. So no excuses for getting this incorrect. When people do this wrong on the test, the reason why they do it incorrectly is they go way too quick. Take your time. We start with the beginning. X times x. X times negative 4. X times negative 2i roots of 3. Negative 2xi roots of 3. Every once in a while, you get kind of your first times in mathematics. So first time you've probably ever written an xi roots of 3, right? You wrote that and you're like, oh, that's new. I bet that happened for you, didn't it? Like, I've never written an xi. Probably haven't. Okay, then we go to our negative 4. Negative 4 times x. Negative 4x. Negative 4 times negative 4. And negative 4 times negative 2i roots of 3. Positive 8i roots of 3. As I said last hour, we're on the home stretch. We are! Got the last one here. We have 2i roots of 3 times x, and that's going to give you positive 2xi roots of 3. We have 2i roots of 3 times negative 4. Negative 8i roots of 3. And then we have the last one. I'm going to need a separate page because just so you guys can follow what's happening here. Can I go to a different page? 5, 4, 3, 2, 1. Gone. Okay. 2i roots of 3 times negative 2i roots of 3. So that's what we have to do now. That's our last term. Let's think about what's 2 times negative 2. Negative 4. What's I times I? Negative 1. And what's the root of 3 times the root of 3? 3. So you got negative 4 times negative 1 times 3 is 12. If you've done everything correctly, everything that has an I in it should cancel. In fact, when people do these a lot, they just don't even multiply the i's anymore because they know they're all going to cancel. They're just like, well, it's going to cancel, so why do it anyway? So you see here you have negative 2i roots of 3 and positive 2i roots of 3. They go away. You see you have positive 8i roots of 3 and negative 8i roots of 3. They go away. So you can see that you have the x plus 3 on the outside, and then you have x squared. Good. Negative 4x and negative 4x make negative 8x. And then 16 and positive 12 make 28. That looks a little bit better, doesn't it? Okay, let's finish it off. We're almost to the end where we have a polynomial, x times x squared, x times negative 8x, negative 8x squared, x times 28, 3 times x squared, 3 times negative 8x, and then 3 times 28, 84. What is my x squared term going to be? Minus 5x squared. What is my x term going to be? For x. That is the polynomial that has solutions of negative 3, 4 minus 2i roots of 3, and 4 plus I, or 2i roots of 3. Just in case you're curious. Isn't that wonderful? And now you know. That's the extent of our learning for Chapter 3. I would like to do Section 3.6, but we're going to have to save that for a later date. So, your test is going to be confined to Sections 1 through 5. All the assignments are on the board. I don't believe you had a single worksheet, did you? So, that's it. I've condensed the learning. I would say last year I had 4 more assignments on top of that, but they also had more time. We made this a little bit quicker. We shortened stuff up. I think you're going to be good to go. I'm very confident that we're going to have a lot of very high scores on this test. I think when you go through the study guide, you're going to feel excellent about your ability to perform well on this test. But you have to take ownership of your learning between now and next week, Tuesday. Tomorrow you have the full hour to ask questions on your homework. If you want to start the study guide, that's fine. Here is your assignment in case you didn't already see it, because I know YouTube Nation cannot. 3.5, page 306, numbers 1, 3, 7, 9, or 19, 21, 31, 32, and 35. There you go. Hope to see you soon, Preston, and Taylor, and Haley. Wow. They just choose to not show up. Anybody want to give a shout out to anybody? What'd you say? Oh, okay. See you, wake up! Terrible kids.